Here's a quick question testing your understanding of when to use what type of hypothesis test. Studies indicate that about 10% of polar bears weigh more than 1,000 pounds. A biologist studying the bears thinks that percent might be too high. From a random sample of polar bears, the biologist found only 8% of the sample weighing over 1,000 pounds. Which of the following is the most appropriate method for the biologist study? I'll show you what the right answer is by process of elimination, but first, let's just come up with the right answer just straight from the question. The biologist thinks that the reported percent of 10 might be too high, so we would be looking for a lower tail test. The biologist thinks the true proportion is actually less than the reported proportion, although the multiple choice answers don't actually address whether this is an upper tail or lower tail or two-tail test. Beyond that, we know that this is a one-sample test. We've only collected a single sample. There's the whole population of polar bears, and studies indicate that about 10% of them weigh more than 1,000 pounds, but there's no sample there. The only sample is the one from the biologist, where we have a proportion of that sample weighing over 1,000 pounds. Okay, so it's a one-sample test for a proportion. And for proportions, we use z-tests. We use normal distributions. That's why it's a z-test, because we use a z-score. And of course, it is a population proportion because we don't do tests for sample proportions. We know what the sample proportion is. This is a one-sample z-test for a population proportion. Again, the fact that it's a proportion is indicated to us clearly by the percents. Percents are proportions. So without even having to look at the answers, we can instantly pick out the correct response as B, a one-sample z-test for a population proportion. If we were a little less confident, we could also solve this just by elimination. Any response saying that we need a test for a sample proportion can instantly be eliminated. So that gets rid of D and that gets rid of A. Again, that's because we don't do tests for sample proportions. We know what the sample proportions are. We do tests for population proportions. We can also get rid of the response that mentions two samples. We don't have two samples. We have a single sample of polar bears where 8% of them weighed over 1,000 pounds. Since we only have one sample, we can certainly also disregard the response that mentions a difference in proportions. We're not talking about two different populations and what the difference in proportions might be, and we certainly don't have two samples to complete such a test. So response C is also incorrect. Again, we arrive at B. And real quick, if you actually wanted to carry out this test, well, we don't actually have enough information because we don't know what the sample size was. But if we just assume the sample size was, say, 100, this is what the hypothesis test would look like. The null hypothesis would be that the true population proportion is the reported 10% by the studies, but the biologist would have an alternative hypothesis that the true proportion is actually less than 10%. We would get our standard deviation, and then we'd be able to calculate the test statistic, and we would find a p-value of 0.252, which is quite large, and so we would fail to reject the null. I can also show you this test on the GraphenCalc 83, a really cool calculator app on iOS. Here I've done the test. X equals 8, n equals 100, and you can see the p-value is 0.252. However, if we were to scale up the sample and suppose that still 8% of the polar bears weighed over 1,000 pounds, let's say we get 800 polar bears that weighed over 1,000 pounds, and so now our sample was actually out of 10,000 polar bears, then we actually get a really small p-value. So you can see how this smaller proportion in a much bigger sample is far more convincing evidence. In this case, we would reject the null. Hope this was helpful. Let me know in the comments if you have any questions.
Parted hearts and heavy minds weighed down by the catalyst, sinking to the stomachs that plummeted at the accident. Shot off all my habits to addicts ripped by a catapult, pulled apart the patterns in man that stood as a manifold. Man of many pains with a number that he had to call, calculate the damage of himself and what's collateral, being told he's not enough until he swallowed.